Hello everyone. So we have been discussing about control systems and its basic principles. So in this session, I am going to introduce you guys to a software called MATLAB, which is a short form for Matrix Laboratory. This package or software was developed by the company called MathWorks. Okay, so this software can be extensively used for control system analysis and design purposes. So we will get to the details. So you can see here, this is my desktop. Okay, so this is my MATLAB icon. Okay, so if you double click on this thing, a window will pop up. Right? So this window is called the command window. Okay, you can see here something is blinking. So this window is called the command window. Okay, so here you can type different commands, execute that, and so on. Okay, so before we begin, some basic aspects. So to know which version of MATLAB I am using, there's a command called ver version. Okay, so just type ver and enter. So it will display what is the version. So you can see it is R2018B. That means this is 2018B version. Every year, MATLAB will release two updates, version A in the first 6 months and in the later half, version B. So since this year is 2021, right now, 2021B version should be available. Okay, but my version is 2018B. So if you scroll down, you will see what are the packages that are being installed in this thing. Aerospace, control system toolbox, curve fitting, DSP, global optimization toolbox, etc., etc., etc. Okay, so all these things have been installed in this particular package. Okay, now this is called command window. So to clear command window, there's a command called CLC. CLC means clear command window. Okay, everything will disappear. Okay, now suppose you want to adjust the layout. So normally when you open MATLAB command window, everything will be having a white background color. Okay, why this is black in color? We can change by going to preferences option. You can see here there's a preferences. Just follow the the mouse movement. Okay, this is preferences. Click here. You will see what are the options that are available to you. Okay, so if you click on the fonts, you can increase the font size or decrease the font size. Okay, personally I have used 20 font size. You can use whatever size you need. Okay, then coming to colors, there's an option called color here. Okay, so here just to suit my eye requirement, I have changed the background color. Okay, viewing at a dark black background is comfortable for my eyes, so I have changed my background color from white, which is default, to black, so that it meets my requirement. Okay, likewise you can use different colors for all these commands, all the warning messages, and so on. Okay, so I have made use of this preferences option. Fine. Now here you can see another option called layout. Okay, so what is layout? So right now I have only this command window. Okay, so if you wish, you can have your workspace also to be displayed. Okay, so workspace will be displayed here. So in MATLAB, workspace is anonymous, or workspace is analogous to what is called a memory. Okay, say for example, let me type A equal to 2. Okay, so I will type B equals A plus 3. So naturally it should be 5. So you can see here, everything is displayed here. This is what is called a workspace. Okay, now let me type CLC to clear out the command window. Is the memory cleared? No. For example, if you type A, it will display the value 2. If you type B, it will display the value 5. So that means the values are still stored in the workspace or in the memory. So CLC will just clear the command window, but it will not clear the memory or the workspace. So if you want to clear the workspace, then the command is clear space all. Clear space all. Okay, that will clear the workspace now. So if you type A, it will show some error. Okay, undefined variable. Now let me type A equal to 2, B equal to 5. Okay. Now if I type clear space all, what happens? It will clear the workspace, but it will not clear the command. For example, see what is happening right now in the memory. There is A and B. Okay, I am now going to enter clear space all. What happens? The workspace has been cleared, but the command window is not clear. So to clear the command window, the command is CLC. Okay, so these are just some basic commands. And suppose you do not know an exact MATLAB command. Okay, there are many MATLAB commands. We will see most of the commands pertaining to control system toolbox. Okay, suppose you do not know a particular command, then you can find that using the command look space for. Okay, look space for. Say for example, I want to find a particular command related to the transfer function. So I will simply write the catch word. Look for transfer. Is it a single word? I forgot. Look for, it's a single word. Okay. Look for space, that catch word you give. Okay. And enter. What happens? MATLAB will display all the commands related with the catch word transfer. It will take some time. Okay. It is busy. You can see here, the bottom left, it is displayed as busy. Okay. So all the commands related with the catch word transfer will be displayed by MATLAB. Okay. It will take time. Let me stop here. Yeah. Okay. So that is how to find a particular related command in case you do not know the exact command name. Now suppose you know a command name. Say for example TF. TF is a command used in MATLAB for transfer function. Okay. But you do not know what's the purpose or what's the syntax, how to use that. Then the command is help space TF. Okay. And enter. It will display the syntax and the usage. Okay. So let me repeat that. Look for is used if you want to find a command, MATLAB command. Help is used to know the details of that particular command. Okay, so look for space catchword will display all the MATLAB commands related to that particular catchword. Are you getting me? Whereas help space MATLAB command will give you the details of how the command is to be used. That's the difference between look for and help. Okay. Now let us try some very commonly used MATLAB commands. Okay. See, yes, I'll clear the command window, right? Now, in control systems, we are mostly dealing with complex numbers. Okay, so there's a command called complex. What does it do? How will you find what it does? Help space complex. Okay, so it will display the syntax and the usage. Okay, you can define a complex number. Say, for example, 3 plus J4. How will you do that? C equal to complex of 3, 4. C equal to complex of 3, 4. Okay, will display the complex number 3 plus J4 or 3 plus 4i. Okay, that is the purpose of the command complex. Then we have conjugate. What will conj, C-O-N-G, help space conj. What it does? It will generate the complex conjugate of the value. Okay, so here we have these in C. Okay, so conjugate C, conj of C. So it will be 3 minus 4i. Okay, then real. Real means what? It will display the real part of the value. Okay, it is 3, right? Then there is imaginary, IMAJ, imaginary of answer. If you use answer, what happens? It will show some error because there is no answer is the default variable name used by MATLAB. Okay, if you do not specify a variable name, okay, then MATLAB will use by default it will use the variable name ANS. Okay, so let me define. So we have C here. Okay, so imaginary of C should display what? Should display 4. Okay, so in this way you can extract the real part and the imaginary part. Now, if you want to find the absolute value, what is the absolute value of 3 plus J4? 5. How will you find that? Root of A square plus B square. So absolute value of C will give you 5. Okay, so these are some common commands. Now, if suppose you want to find the angle, okay, this gave you absolute value. What's the angle of 3 plus J4? It is 3.13. Is it not? So if you want to find that, then the command is A tan 2D. Okay. If you use A tan 2D, then you will get the angle in degrees. If you simply use A tan 2, you will get angle in radians. Okay. So A tan 2D, y comma x. So it should be 3, 4. So it is 4 comma 3. Okay, so the angle will be 53.13 degree. Okay, so this is how to extract the angle part of a complex number. Is that clear? Now moving on. Suppose you have a polynomial. Okay, for example, say polynomial, say p equal to say 3s square plus 2s plus 1. Okay, how will you enter the polynomial values here? It should be starting from highest power of s and the decreasing order. Okay, so this means MATLAB will take this as 3s square plus 2s plus 1. That's the meaning. Okay, MATLAB will define a polynomial p as 3s square plus 2s plus 1. Suppose I want to evaluate 3s square plus 2s plus 1 at say 1. Okay, I want to evaluate 3s square plus 2s plus 1 at s equal to 1. So what should you get? 3 plus 4, 6 you should get. Okay, so for that the command is polyval. Okay, polyval p comma 1. So it should give you 6. Okay, this is how to evaluate a particular polynomial at a given value of the variable s. Okay, then suppose you want to find the roots of this polynomial. So the command is roots of p. Okay, where are the roots of p? They are minus 0.33 plus minus j or I 0.4714. In this way, you can calculate the roots of the given polynomial. Now, suppose you may have to generate an array of ones. There's a command ones, O-N-E-S. Okay, ones of m comma n, where m is the number of rows and n is the number of columns. Say 1 comma 2. So it will generate an array with 1 row and 2 column of ones. Okay, similarly, you can have zeros of say 2 comma 1, 2 rows and 1 column. It will generate an array of zeros. Okay, then comes identity matrix. Okay, EYE, identity matrix I of say 3. You will have an identity matrix of order 3. Okay, diagonal matrix of order 3. So if you want to know more about that, help space I, EYE. Okay, that will display the syntax and the usage. Are you getting me? Now suppose you have a figure. Okay, say for example, let me define a line, x equal to say 1 is to 10. Okay, if I put a semicolon and then if I enter, I cannot see the value, the output in the command window. That's a difference. Okay, I will show you here. See, now there's no output here. Why there's no output? Because I had added a semicolon. Now suppose the same command without semicolon I am entering. Now what happens? Oh, sorry, this is a mistake. X equal to is 2. Okay, it is a row vector. Why now the output is displayed in the command window? Because semicolon was missing. Okay, so let me define this. So x is a vector with a row vector with 10 columns. Similarly, y equal to x. So that means y will also be a vector, say of the same dimension and as x. So plot x comma y. Okay, you will get a straight line. Okay. So you can see that a plot has been generated, right? Now suppose for some reason I want to find what's the value at this point. How can I find that? For that, there's a command called ginput. Okay, and within the round brackets, you specify the number of points at which the x and y coordinates are to be found. Say for example, I want to find the x and y coordinates at 2 points. Okay, so I will give ginput 2. What is 2? 2 represents the number of points whose x and y coordinates are to be determined. Okay, now you enter and what happens? The figure window will pop up. If you move the cursor, you will see that a crosshair kind of thing will appear. Okay, so we wanted to find the x and y coordinates of 2 points. Okay, so I will click here, make a click here at the first point. Okay, then I will click here, say between 8 and 9. Okay, now what happens? This is the x1, y1. X1 was 5.6141. Corresponding y coordinate was 5.5787. Similarly, x2 was 8.5588 and y2 was 8.4650. So the x and y coordinates of both the clicked points will be displayed in the command window. Okay, that's the purpose of ginput. So you can find the x and y coordinates of any number of points. So if you want to find x, y coordinates of say 8 number of points, you give ginput within round bracket 8. So 8 times you have to click in the graph. Then only you will see the output in the command window. Okay, that's to be remembered. So now we will go to see how to use for the control system. Okay, suppose we have a transfer function g of s equals 2s cube plus 5s square plus 3s plus 6 whole divided by s cube plus 6s square plus 11s plus 6. Okay, we want to enter this into transfer function form. So what we have to do first we need to define the numerator coefficient and the denominator coefficients. Okay, so I will write program like this: num equals. So as I said before, the coefficient should be arranged in such a way that the power of s is descending. So highest power is 2 here, then 5, 3, 6. Okay, then I will define denominator equal to what? 1 space 6 space 11 space 6. Okay, now I will define my system. I will call my system as this equal to tf. This is the command tf of num comma d. Okay, so this thing will be displayed. Let us see that. So I have before that I forgot to tell you one more thing. So by default, MATLAB will save all the programs in some default folder. Okay, so how to find that? You just type pwd, present working directory, and enter. Okay, so right now in my system, all the programs are being stored in the C drive. Okay, so if you want, you can create a folder of your own at whatever location you prefer to, and make MATLAB to save all the files into that particular folder. For example, let me create a folder on the desktop. Okay, say ABC. So here I am right clicking new folder, and I will call it as ABC. Some folder name I have given. Okay, now what happens? I will go to MATLAB. I want MATLAB to save all the programs in the folder ABC. So what I should do? I should make use of what is called the path browser. What is the path browser? It is given by this thing. You can see here a green arrow going down from an open folder. Okay, click there and point to that particular folder. It's my desktop. So I should go to desktop. Where's desktop? It's desktop. Then I need to point to ABC. Okay. Now if I type pwd, my folder name ABC should appear. See, it is ABC folder, which is in the desktop, which is in this C drive. Okay. So unless I shut down MATLAB, all the files will be stored in the folder ABC. Okay. So let us open a new thing. So there's another feature in MATLAB called new live script. Okay. So what's the specialty of new live script? You can execute the program there itself. Okay. If you want to run a program, you can have it executed there itself, then and there itself. Okay. So this we will, okay, maybe we will take this up. So what was our transfer function? Our numerator was 2 space 5 space 3 space 6. 2 space 5 space 3 space 6. Okay. Then denominator was 1 space 6 space 11 space 6. Okay. 11 spaces, right? Then this equals tf of num comma d. Okay. So now you can run this thing and see what is the output here. Okay, it is running. That's why it is showing something circling. So you will see the output here in this half. See, this is the transfer function. 2s cube plus 5s square plus 3s plus 6 divided by s cube plus 6s square plus 11s plus 6. That's what we have written. 2s cube plus 5s square plus 3s plus 6 whole divided by s cube plus 6s square plus 11s plus 6. Okay. This I will close. Fine. Now let us come to the next problem. So this is here the transfer function has been expressed as a ratio of two polynomials. Numerator is a polynomial in S, denominator is a polynomial in S. The same thing can be expressed in partial fraction form. What is partial fraction form? A by S plus alpha plus B by S plus beta plus blah blah blah, like that. Okay. For that we have a command. That command is called residue. Okay. If you have any doubt, you can type here help space residue. Okay, it will display what is the syntax and the usage of the command residue. Okay, so already we have numerator denominator here. So straight away I will write r comma p comma k square bracket r comma p comma k equal to what? Residue of num comma d. Okay, so what it does, it will generate an array, 3 arrays, one r array, one p array, and one k array. Okay, like this. So now let me put a semicolon and run this. So you can see here in the workspace, num, then everything is being stored here. Okay. So you see, as I said before, it will generate 3 arrays. Okay. Square brackets are used to indicate the output values or output arguments. Okay. And round brackets are used to indicate the input arguments. Should not confuse. Okay. So here in this command, R, P, and K are the output that we need. So they are representing square brackets. Whereas num and in were the input arguments. So they are given in the round brackets. Okay. Now, what will be this transfer function? How will you define this? The transfer function will be minus 6 by s plus 3 minus 4 by s plus 2 plus 3 divided by s plus 1 plus 2. Okay, let me express it here. Let me write it here. What will be the transfer function? It will be nothing but minus 6 by s plus 3, then minus 4 by s plus 2 plus 3 divided by s plus 1 plus 2. That's how it gives the output. Okay. Right? So minus 6 by s plus 3, minus 4 by s plus 2, plus 3 by s plus 1 plus 2. That's what is written here. Okay. So this is the partial fraction form of this transfer function, which is expressed in which has been expressed in the same thing expressed in the polynomial form is now expressed as partial fraction form. Clear? So the command is residue. Okay. In case if you have forgotten that, you just type help space residue at the command prompt and enter it. Okay. Let us try an next example. Now suppose, so you see, we had already discussed what are poles and what are zeros. What are zeros? Zeros are those values of s which make a transfer function 0. And what are poles? Those values of s which make a transfer function infinite. Okay. So if you wish, you can express transfer function in pole zero format also. Okay. If you wish, you can express the transfer function in pole zero format also. Okay. So let us try another example. Let us try this example. Say g of s is equal to 4s square plus 16s plus 12 whole divided by s raised to 4 plus 12s cube plus 44s square plus 48. Yes. Okay. So here I want to express this in pole zero format. Okay. So there's a command called tf2zp. tf2zp. Okay. So if you want to know about its usage, just type help space tf2zp. Okay. Help space tf2zp. Okay. It will display the syntax and the usage. Okay. So z comma pk equal to tf2zp num commanding. Okay. So now that we have a different transfer function. So what will be a num and in? Our num will be what? Our num will be, can you tell me what will be num? 4 space 16 space 12? No. Correct. No, 2. Yes, correct. 4 space 16 space 12. Correct. Okay. Then what will be my din? It will be 1 space 12 space 44 space 48. Are we done? No. You should start from highest power of s to s raised to 0. So since there is no constant term, you have to add 0 from your hand. 0 like this. Okay. So this will be our numerator and denominator. Okay. This will be our numerator and denominator. So let us see that 4 space 16 space 12. Num is 4 space 16 space 12. num is 4, num is 4 space 16 space 12. And what is denominator equal to? You can use the same variable names also. Okay, MATLAB will wipe off the older data in the variable name. Okay, if you want, I can give a different numerator, say num1 or num2. Okay, if you use num, the latest value that you enter will be stored in the variable name num until. Okay, so no need to bother about that. So what is denominator? Denominator is equal to, what is our denominator? Denominator was 1, 12, 44, 48, 0. 1, 12, 44, 48, 0. 1, 12, 44, 48, 0. Okay. Now what's the command? Z comma P comma K. So Z comma P comma K equal to what? TF2 ZP num comma din. Okay. Now if you run this, what happens? So I will just comment these things. Okay, for my convenience. Huh? So what you have to do, you select all these things, and then there's a comment signal is there. This percentage signal that will comment all these lines. Okay, let me run it. So what happens? Again, it will generate three arrays. One is Z. Okay, this is P and this is K. So how will you write the transfer function? The transfer function will be what? This is gain K. So 4 into S plus 3 into S plus 1. They are in the numerator terms. Okay, 4 into S plus 3 into S plus 1 whole divided by S into S plus 6 into S plus 4 into S plus 2. Okay, S into S plus 6 into S plus 4 into S plus 2. Okay, so this way you can write the transfer function in a pole zero gain format. Okay, so what did we see? We saw transfer functions being represented as a ratio of two polynomials. Transfer function being represented in partial fraction forms using the residue command, and partial transfer functions representing pole zero gain format using TF2ZP command. Okay, so in three different forms you can represent your transfer function. Okay, now let us try one example. Let us take up one example. Okay, so we need to obtain the transfer function. That's the question. Obtain the transfer function. Obtain the transfer function. Okay, so you are given some conditions. There is no finite zero. There is no zero. What do you mean by no zero? There is no zero means there are no finite zeros. Okay, that's the meaning. Then the poles are at S equals -1 plus -2j, and the gain is given as 10. We have to obtain the transfer function. So what will you do? What will you do? You have to find the transfer function. Okay. So how will you find this? So similar to TF2ZPK. So here we had used the command TF2ZP. Okay. So there's a reverse command ZP to TF. That means here you are given the numerator and denominator of the transfer function. We wanted to find its pole zeros and k. Okay. But if you are given the pole zeros and k, then you can find the transfer function in the polynomial form with the help of the command ZP to TF command. Okay. So how to do that? Like this. So what we need to do, first you need to define. There is no finite zero here. So Z will be a null thing. Okay. Then what's your P? P will be -1 plus 2j plus 2 star I. Okay. Then it should be a column vector. Okay. Then it will be -1 minus 2 star I. And k equal to 10. Then what's the command? Num comma din equals ZP to TF. Z comma E comma K. Okay, let me type it here. So Z is a null vector. Okay, Z is a null vector. So I will comment these things. Now, Z is a null vector. Okay, and what is P? P is nothing but -1 plus 2 star I semicolon. That means next row. -1 minus 2 star I. Okay. So this is P. Then I now I need to define K equal to 10. Okay. Now what's the command? Num comma din equals ZP to TF Z comma P comma K. Okay. Let us run this and see what is the numerator and denominator. Oh, did I make a mistake here? This should be a square bracket actually, okay? Because num and din are the square bracket outputs. Now you run. This is the numerator and denominator. Okay. So now what will be my transfer function? I can define this equals TF of num comma din. Okay, so you can see here, this is the transfer function 10 divided by s square plus 2s plus 5. Okay, so in this way, you can generate the transfer function. Okay, now this is not the only way of representing a system. There is another method technique called state space representation. Okay, what is state space representation? This is useful, particularly when we have MIMO systems. Okay, multiple input and multiple output. Okay, this is the general form. X dot equals y ax plus bu and y equals cx plus d. Okay, this is called state space form of representation. Okay, this transfer function form is useful just to solve textbook examples, but practically systems are MIMO, multi-input, multi-output systems. Okay, so in such cases, we have to go for what is called state space representation. Okay, so why there's a bar here? Bar means it's a vector. Okay, x1, x2, etc. up to xn. But x bar dot means x1 dot, x2 dot, etc. up to xn dot, like that. Similarly, u is a vector or an array, to be more precise. Okay, so what is a here? A will be an u is a vector. Huh? A is an array. A, B, C, D are arrays of appropriate dimensions. Okay, say for example, you can we will see more of this thing in detail later. Okay, so for the time being, just keep in mind you can convert transfer function to state space and state space back to transfer function. That's possible. Okay, so in MATLAB, there's a command called TF to SS. TF to SS, what does it do? What does it do? It will convert transfer function to state space form. There's another command SS to TF. What it does, it will convert the state space form to transfer function form. Okay, so we'll just look into one or two examples. Okay, so I will comment these things as well, right? Now assume that we have a transfer function. Okay, say g of s equals, assume we have a transfer function g of s equals s divided by s into s plus, sorry, s divided by s plus 10 into s plus 10 into s square plus 4s plus 16. S square plus 4s plus 16. Okay, we need to convert this into its state space form. Okay, so what we have to do? We have to define numerator and denominator as before. Okay, one way of it, so you can see a denominator comprised of two multiples. Okay, either you can expand this polynomial or there's a command called CONV. Okay, this command CONV will straight away find the product of these two polynomials. Okay, how to use that? This convolution basically. Okay, convolution of, so first you put a square bracket, enter the first polynomial coefficients 1 space 10, comma, then you open another second square bracket, enter the second coefficients of the second polynomial 1 space 4 space 16, square bracket closed, round bracket closed. Okay, so in one shot you can find what's the equivalent of the product of the two polynomials. Okay, so let me define that here. Huh? So our numerator num was how much? Num was s. Okay, our numerator was s. So what will be our numerator here? Our numerator will be 1. Only that much? No, 1 space 0, because our coefficient of s is 1, coefficient of s is 0 is missing. So that means it will be 0. So this will be our numerator. So we can enter our numerator as 1 space 0. 1 space 0. Okay, then we can write our denominator as convolution of, okay, so within square brackets, you enter the coefficients of the polynomials. So what was the first? It was 1 space 10. Then second one was 1 space 4 space 16. 1 space 4 space 16. Okay, if I have any doubt, I will show you. I will just remove the semicolon of the denominator and show you. Or did I make a mistake here? Num equals 1 space 0. What's the problem here? Condition of 1. Oh, it is a dot here. It's not dot, it should be comma. Again, dot. Be comma. Okay. So you see what happened? Your denominator is a single polynomial here. Okay. So that is there. And now what next? You can have, this is the command. Okay. If you want to know the command, help space TF to SS. Okay. It will convert transfer function into state space form. Okay. ABCD representing system in ABCD form is called state space form. Okay. So TF to SS num comma din will calculate the state space representation. X dot equals AX plus BU, Y equals CX plus BU. Okay. So now our output arguments should be A, comma B, comma C, comma D equals what? TF to SS num comma D. Okay. So it will generate 4 arrays. Okay. What are the 4 arrays that you can see here? ABCD. Okay. So now I have represented my system in ABCD form, in state space form. Okay. So one thing to be noted here is that our we had considered only SISO system. That means single input, single output. That is why our B was a column vector and C was a row vector. Okay. Suppose there are many inputs. Okay. Suppose there are 2 inputs, U1, U2, and 2 outputs are there. Assume there are 2 outputs. Okay. So how many transfer functions you can find? You can find transfer function between Y1 and U1, between Y2 and U1. Okay. Likewise, between Y1 and U2 and between U2 and Y2. So that means you will get 4 transfer functions here, or you will get a transfer function matrix. Okay. So if your input is more than 1, and if your output is also more than 1, then your B and C arrays, C matrices will be an array. Okay, not a vector here. So right now here our B is a column vector. Why? Because we had only 1 input. Right now our C is a row vector. Why? Single row vector. Why? Because we had only 1 output. Okay. So if there are many inputs, then our B would have been an array. If there are many outputs, our C would have been another array. Okay, that is to be noted. And similarly, back operation is also possible, right? You know ABCD, you can convert to num comma din. Let me use that command here. Okay. Now let us see what's the numerator denominator here. So num comma din equals SS to TF. Okay, we are converting now back our ABCD matrices into a transfer function form. Okay. So now you can see what is the transfer function form here. What's the numerator here? Okay. So this equals TF of num comma din. Okay, we know that. So you see here, this was our ABCD matrix and this was the transfer function. S divided by, what is the transfer function? S divided by SQ plus, what is the transfer function? SQ plus 14S square plus 56S plus 160. Okay, so in this way you can do a basic modeling. Okay, so before I wind up, let me show you something more. So if you go to here, you can see here a help option is there available here. Okay, can you see this? Where is that? There's a home. Okay, you go to home, click at home option. Okay, you will see here help. Okay, if you click here help, you will see the documentation. Okay. So you can see here the documentation for all these toolboxes. Okay, what do you mean by toolbox? Toolbox means there will be a set of instructions which are customized for a particular application. Okay, so control system toolbox will contain all the related commands, related MATLAB commands that are used for control system application. Similarly, computer vision system toolbox will contain all the commands that are exclusively used for computer vision and so on. communication toolbox. Okay, they will be grouped under one heading called that particular toolbox. Okay, so communication toolbox means all the particular MATLAB commands used for communication analysis, communication purpose will be categorized as communication toolbox. Similarly, control system toolbox means all the commands related with control system application are categorized as control system toolbox. Okay. Now, what I want to show you is that, say, for example, since we are dealing with control system toolbox, if you click here on control system toolbox, you will see here the different commands that are being used. Okay, getting started. Okay, so how to start? Just click here. You will find all the details. Okay, so what I wanted to say is that it is easy to learn MATLAB by yourself. There's no need of any external help or extra books. Just make use of this help. Okay, for yourself. Okay, then if you click here, dynamic system models. Okay, we had seen, I think, linear system representation. All these things are there. Tunable models, model arrays, basic models, all those things. Okay, so in short, you can learn these things by yourself. There's no need of any help from anyone. Okay, this is one thing, right? So just make use of this documentation. Then, as I said before, this MATLAB was developed by a company called MathWorks. Okay, this is the MathWorks website, right? So if you go here, go to Academia, click there at Academia. What happens? You will be directed to something else. So you can see here for students, for educators, for researchers. Click here for educators. Okay, so if you click here for educators, what happens? Curriculum resources, online teaching, campus-wide license, etc. Okay, so if you click here at curriculum resources, you will see books. You must be knowing that all modern textbooks are accompanied with MATLAB softwares. Okay, every textbook, modern textbooks will be having some MATLAB application. Okay, so you can search here for a particular domain, say control systems. Okay, so whatever books are using, textbooks are using MATLAB for control system application will be displayed here. Okay, and these softwares are freely available. Okay, all MATLAB programs are freely available. Just click on this particular textbook, you will get the combined software. Okay, so this particular textbook has a lot of MATLAB examples. So all the MATLAB codes are available here, free of cost, which you can download and study. Okay, like that, all these textbooks will be having its MATLAB programs. Okay, you can download all the MATLAB programs and go into that, study that. Okay, system dynamics. So you can see here all these options are available. Okay, so the gist is that you can do MATLAB for yourself. Okay, so more of MATLAB we will discuss in the coming class. And let me stop with this. Thank you.